नमस्कार दोस्तों, कम्युनिकेशन के क्वेश्चंस लाई हूँ। इंफॉर्मेशन थ्योरी एंड कोडिंग से रिलेटेड है। तो फर्स्ट क्वेश्चन है, अ सोर्स प्रोड्यूसेस फोर सिंबल्स विद प्रोबेबिलिटीज दिस मच p1 p2 p3 and p4. Okay, the values are given in the question. I'm not going to repeat it. For this source, a particular coding scheme has an average code word length of 3 bits per symbol. The efficiency of this code is, since I'm talking about the information theory. Okay, so there are four probabilities. I can take it as p1, p2, p3, p4. Okay, now efficiency of code. Efficiency of code, this is equal to h by l. This is the formula, right? H is the entropy, this you know. So uh, h, that means entropy of all four symbols with their respective probabilities is the formula pk log base 2 1 upon pk, right? Is this the formula? So you have entropy is equal to half into log base 2 1 by 1 upon 2, right? Then either plus 1 by 4 log base 2 1 upon 1 by 8, sorry, 1 by 4. Then here, as p3 and p4 are repetitive in nature, their symbols are repetitive in nature, so I will write it as twice into 1 by 8 log base 2 1 upon 1 upon 8, right? So here it will be half into log base 2 2 plus 1 by 4 log base 2 4 plus 1 by 4 log base 2, here it is 2, right? So here it will be half into 1 plus 1 by 4 into log base to 2 square is uh, plus 1 by 4 into 3 log base to 2. Okay, so here you can write it as half plus 2 by 4 log base to 2 plus, here you can write it as 3 by 4 log base to 2, it means it is 1, so it will be into 1 plus 3 by 4. So here it will be 1 plus 3 by 4, so it is 7 by 4. Okay, no, I think something wrong has happened. It will be half plus half. So it is 1 4 plus 3, it is 7 by 4. Yeah, it is right. Now efficiency will be h upon l bar. So h is 7 by 4 and l bar is how much? L bar is, as it is given, length of 3 bits per symbol, that means l is 3, so it will be 1 by 3. So it will be equal to 7 by 4 3 is 12, right? So if you are going to divide it, so it will be 12 6 is 72, right? Oh, 1 minute. Okay, if it is 14 by 8 and 2 7 is 14 to 4 8, okay, it is how much? It is 4 3 is 12 and 7. Okay, so it will be 12 5 is 60, 12 6 is, no, it will be 5, then 60, then it is near about how much? 12 nines are 108, 12 8, no, it is around 0.58, it is around 0.58 or near about 0.6, so it is 0.6, so your answer will be 0.6. Okay, next question is, an image uses 1024 into 1024 pixel elements. Each of the pixel can take any of the 8 distinguishable intensity levels. The maximum entropy of the above mentioned image will be, see, the maximum entropy of pixel, it is equal to how much? It is equal to log base to 8, because it is given each of the pixel can take off 8 distinguishable intensity levels. So it is like this way, and here it will be log base to 2q, and it is 3 log base to 2 is equal to 3 into 1, it is equal to 3, right? Now maximum entropy of entire picture. This is equal to how much? It is equal to 1024 into 3. So it will be how much? 1024, it is 2 to the power 10, again 2 to the power 10 into 3. So it will be equal to 3 into 2 to the power 20 bits, right? So this is the right answer. So answer will be here, it is C option, right? Next question is a source generates, see, the question is a source generates three symbols with probabilities 0.25, 0.5 and 0.25 at a rate of 5000 symbols per second. The most efficient source encoder would have average bit rate as, see, average bit rate. If you go on entropy chapter, entropy, that formula of entropy, it is P log base 2 1 upon P, right? So if the question is about saying that most efficient source encoder would have average bit rate it is asking for. See, average bit rate is equal to 5000 into, it is H. Okay, so when you are going to calculate H, it will be like 0.25 log base 2 0.25, and here see 0.25 is repeating, so I can write it as 2 into 0.25 plus 0.5 log base 2 1 upon 0.25. So it is 0.5, right? And it is, it is log base 2 2 square plus 0.5 log base 2, it is 2. So it is, zero point 0.5 into 2 log base to 2 plus 0.5 into 1. 0.25 just 10 हो गया, it is, and it is, plus 0.5. So it will be 1.5, right? Okay. Now you have average bit rate is how much? As it is asking for average bit rate, so it is equal to 5000 into 1.5. So it is 7500 bits. Okay, this is the question. Next question is like it is if a source emitting four alphabets with probabilities p1 p2 p3 p4 and the entropy of this source is h of x1. If another source emitting four symbols with probabilities p1 plus delta, p1 minus delta, p3 minus p4, and the entropy of this source is h of x2, then which of the following is correct if delta is a small positive constant? See, entropy will be maximum. Entropy is maximum if the probability of symbols is equal. If the probability of symbols is equal, entropy will be maximum. That is the variation in probability of different symbols is 0, right? Entropy is maximum if the probability of symbols is equal, like if P1 is equal to P2 is equal to P3, that is the variation in probability of different symbols is 0. There is no variation. So in X2, the variation in probabilities here, P1, P2, P3, P4 are the four probabilities, right? P1, P2, P3, P4 are the four probabilities, and entropy of this source is H of X1. If another source emitting four probabilities with, if here we are adding plus delta, then the entropy of this source become H of X2. So in X2, the variation in probabilities, in X2, the variation in probabilities are more when compared with x1. Therefore, h of x1 is greater than h of x2. Okay, so the answer will be what? Here B is the right option, right? Next question is, if x is a Gaussian random variable with mean 0 and variance is 10, then the differential entropy of x is, this you should know the formula, differential entropy is equal to h of x, and this is equal to half log base 2 pi e sigma square. So this is equal to half log base 2 into 3.14, and e is what? See, sigma square is variance, so it is equal to 100. 10 square हो गया, and e is natural logarithm, it is equal to 2.7, right? So when you are going to solve it, you get it as 3.8 bits. So this is the formula, 3.8 bits, right? Okay, so this is the right thing, and what you should be knowing that the differential entropy is used to calculate the entropy for continuous sources. It is used to calculate the entropy for continuous sources. That means h of x is equal to integral f x of x log base 2 1 upon f of x of dx. But here I am not going to give the derivation. Okay, so for any, the differential entropy will be maximum when the fxs is Gaussian distributed. This differential entropy is maximum if PDF probability density function is Gaussian distributed. Now for the given sigma x square, जो maximum value होगी वो क्या होगी, अगर आप निकालोगे तो एच एक्स विल बी इक्वल टू, यही मैक्सिमम वैल्यू है, हाफ ऑफ लॉग बेस 2 पाई ई सिग्मा एक्स स्क्वायर. ये फॉर्मूला है डिफरेंशियल एंट्रोपी का. तो ये कभी डिफरेंशियल एंट्रोपी तभी मैक्सिमम होगी उसका पीडीएफ गॉसियन डिस्ट्रीब्यूटेड होता है, राइट? नाउ नेक्स्ट क्वेश्चन इज व्हाट? नेक्स्ट क्वेश्चन इज here I have solved the fifth one. Okay. Next question is, an AWGN channel is used to transmit the symbols at an SNR of 30 dB. The channel capacity per symbol in this channel is, see, you have signal to noise ratio is equal to 30 dB. That means if I calculate it in ratio, then it will be 10 log base 10 30, and it will be equal to how much? 10 log base 10 30, no, 10 log base 10 x. Okay, so x is equal to how much? It is log base 10 x is equal to 3, which implies x is equal to 10q. So this is your SNR. Okay, it is in ratio. Now what happens? It is asking the channel capacity per symbol in this channel. You know that channel capacity is equal to how much? Half log used to transmit the symbols. You know the formula, C is equal to D log base 2 SNR. This you know the formula. B is the bandwidth, SNR is the signal to noise ratio. Now signal to noise ratio is what? It is the ratio of the signal power to noise power. But what is going to happen, that it is the bandwidth is not given here, right? The bandwidth is not given here. So here I can write it as B log base 2 1 plus signal power. If it is P, then N naught B is the noise power in bits per second. Now P by N naught B is the SNR of the channel. So I can write it as B log base 2 and then 1 plus, I can write it as SNR. Okay, I can write the formula was B log base 2, I'm sorry, it was B log base 2 1 plus SNR. Yeah. So B log base 2 1 plus SNR bits per second. So this was the formula. So B, the channel capacity per symbol is B log base 2 1 plus SNR. So yeah, P is the average transmitted power of the signal. Okay, so what it is going to happen, again if I read the question once again, an AWGN channel transmits the symbols at an SNR of 30 dB, it means it is 10q in ratio, and the channel capacity per symbol in this channel, then I will do it as half log 1 plus log base 2 1 plus SNR is how much? It is 1000. Okay, So it will be equal to half log base 2 1 comma 0 0 1. So it is will be equal to half log base 2, it is 10 cube. Okay, now you are going to calculate it. So it will be equal to around 5 bits. Gel capacity per symbol. Okay, so the answer will be this way. The answer is 5 bits. So if you have any doubt, you can comment me. So I have solved 6 questions related to information theory and coding. If you like my channel, please like, share and subscribe. Okay, thank you very much.